Director's note: this concludes Christian Friend's translated portion. The following portion was translated by Benjamin Stevens. Billy says, thanks, your explanation says more than I expected. Then I still have another question regarding CFCS. Concerning this, you once told me that certain gases, which are stored under the bottom of the sea and which rise up, cause even greater damage to the ozone layer than CFCS. Now, I no longer know what gas this was and out of what it arises. Quetzal says it concerns methane gas, which is stored as methane hydrate under the sea. Billy says, at that time, you said that often enormous clouds of gas bubbles of this methane gas detach from the seabed, like, for example, in large masses in the Bermuda Triangle. These gas bubbles then rise to the sea surface, where they form huge whirlpools, through which ships into the sea sink when they run into them, as the ships, due to the numerous gas bubbles in the water, are no longer carried by the water. If the gas clouds then ascend over the sea and fly into airplanes, then the methane gas becomes ignited by the engines or nozzles, whereby tremendous explosions arise and tear the airplanes into the smallest pieces. Is this right as such? Quetzal says that is correct. Billy says I might have to ask about it again later, because since my breakdown, I forget some things again and again. But now, another question that also has reference to a natural phenomenon, namely to lightning. Although most flashes of lightning shoot out into the outer layers of the atmosphere and partly even into the outermost layers and beyond that, as I saw several times, when you took me far beyond the earthly atmospheric layers, about 5% or so still shoot down to the ground and cause all sorts of disaster. And since there are more and more people as a result of overpopulation, more and more people are also hit by lightning, which usually has deadly consequences, with few exceptions. Now, it is always said that lightning would hit the highest structures in each case because these would attract the lightning, so even trees, mountains, and buildings, etc. Also, it is said that a person in the open can protect himself against lightning by lying down on the ground or by putting himself into a squatting position in such a way that he pulls his knees up to his chest. Thus, a person should offer the smallest attack area to the lightning. Does this correspond to the facts, or is this an inane story, and are there actually different types of lightning, and how do these arise? Quetzal says it is not correct, in terms of the fact that only high objects are hit by lightning, as it also isn't correct that a person cannot be struck by lightning if he is lying on the ground or is in a squatting position. It is true, however, that there are different types of lightning. Thus, the following is to be explained when thunderstorms emerge. These take place in so-called thunderstorm cells, in which differently sized densities of space charge arise. Once this concentration of space charge reaches a field strength that exhibits values of several hundred kV/m, which you can write as follows, as I have noted it to you here: 100 kV/m on the basis of ice particles or water droplets, then leading discharges or conducting discharges form the leading flashes of lightning, thereby causing a reaction that triggers a discharge of lightning sparks. If the flashes of lightning go from cloud to cloud, then this is called cloud-to-cloud lightning. This creates a balance between positively and negatively charged cloud centers or thunderstorm cells. Then there is the cloud-to-space lightning, which shoots out, under certain circumstances, into space and discharges there. Then, the two types of cloud-to-ground lightning and ground-to-cloud lightning are still to be mentioned. Ground-to-cloud lightning is easily recognizable because it descends from the clouds to the ground, and to be sure, with easily recognizable leading flashes of lightning which have many branches. Leading lightning contains a so-called charge tube, which descends to the ground and is filled with the negative charge of a cloud of the thunderstorm cell. The negative cloud-to-ground lightning is the most frequently occurring lightning, apart from the cloud-to-cloud lightning and cloud-to-space lightning. The positive cloud-to-ground lightning originates from the lower, positively charged area of the flash. positive cloud-to-ground lightning flashes, which originate from the upper, positively charged center, are relatively rare. Such flashes of lightning occur almost exclusively at the end of a respective active phase of a thunderstorm cell. The positively charged center only builds up when the negatively charged center is nullified. Such a positive discharge results, then, through a single and very powerful lightning flash, which descends to the ground. It is also to be noted that ground-to-cloud lightning flashes with branches shoot up into the clouds, whereby leading flashes of lightning shoot up from the earth, from mountain tops, towers, and other tall buildings, etc. into the clouds. With cloud-to-ground lightning, a cylindrical tube shoots down to the ground from the negatively charged center of the thundercloud, which is filled with the cloud's charge. In addition, the tube varies in its diameter and can exhibit several tens of meters. Moreover, connected to it is a very thin and approximately 1 centimeter thick, highly ionized plasma core. This leading flash of lightning shoots down to the ground in a jerky and zigzagging manner, and indeed at a speed of about 300 kilometers per second. The jerky pre-shootings of the leading flashes of lightning occur in steps of several 20 meters, whereby the interim times of a step move to others within the range of a microsecond. Once the tip, the head of the leading flash of lightning, has reached a distance of between 10 and several hundred meters, the electric field strength of the objects that are stationary on the ground, such as buildings, towers, and trees, as well as mountain tops, increases in such a way that the electrical stability of the air is exceeded, and then, so-called catching discharges go out of the objects, and the head of the leading flash of lightning shoots toward and meets with these. With this, the point of impact of the lightning on the ground is also determined, namely a mountain top, a tower or tree, some building, an animal or a human, out of which the catching discharge has gone. This also explains that even a human being emits such catching discharges, but with him, the fact still remains that he generates electromagnetic vibrations through his brain, which reach several meters of expansion, which send out catching discharges, and which form very strong attraction points for the head of a leading flash of lightning. Thus, it is also of no use if human beings remain lying down or in squatting positions in open areas when thunderstorms occur, which are associated with lightning. Real protection for human beings only occurs in caves or in enclosed buildings or in completely closed vehicles and aircraft, etc. If the head of a leading flash of lightning and a catching discharge collide, then the catching discharge shoots into the leading lightning tube at about 100,000 kilometers per second and, within a few milliseconds, allows the stored charge of lightning to discharge to the ground or to the object out of which the catching energy has gone. This, then, is the moment when the actual lightning discharge becomes visible, which lights up very brightly and dazzles the eye. The spark channel created by the leading flash of lightning is heated very strongly, by what means the main flash reaches a temperature of several tens of thousands of degrees Celsius. At the same time, the pressure of the flash rises to about 100 times the normal atmospheric pressure and explodes, through which the crash of thunder arises. Due to the sudden main discharge of the leading lightning tube, a so-called surge current shoots, within milliseconds, into the object struck by lightning, namely a tree, a building or a tower, a mountain, a ship, airplane, automobile, animal, or person, etc. The surge current of positive ground-to-cloud lightning has a similar course, but with its discharge from the upper positively charged center in the thundercloud, the surge current usually lasts about 10 times longer than with cloud-to-ground lightning. Positive cloud-to-ground lightning also transports in itself a much greater energy charge than what is the case with the negative surge current. This is also the reason why positive cloud-to-ground lightning is much more dangerous than just negative cloud-to-ground lightning. But that, dear friend, should suffice as an explanation. In addition to this, there would actually be an entire course to explain in this regard. Billy says that's certainly enough, I think. I didn't want to be instructed in such detail.